This is a quick intro to the CNC wood router slash plasma table that I built a couple years back. We can see that it's a gantry type. Footprint is about 55 inches by 55 inches. Workable area is approximately 36 inches on the X and about
32 inches on the Y. Z travel is 4.5. We want to get into some of the specifics of the design. Each side has 20 millimeter linear rod with bearings. Deflection is handled by, get the light here. In case there's any deflection of the rod, it's kind of a backup reinforcement. It's these bearings that ride on the top rail. They're set with an eccentric, but everything runs pretty smooth. Hopefully you can get back there. On the Z, or on the Y rather, we have a rack and pinion. It's driven with it's geared down rather with a stepper motor. I'm going to go around to the back. It can run at about 500 inches per minute, which is actually faster than I desire. So I have it tuned down. You can see how it's all put together. The steppers actually, you can see the slots. So you have your belt adjustment there. The X-ways are also 20 millimeter rod with linear bearings. And you can see that this bar down on the bottom is what I put into. There was a little bit more deflection there when it was in wood router mode. You don't really get any deflection at all with a plasma cutter because there's no contact. But the rods did have a little bit of deflection when using the routing head. So I put in this bar here. You can see each one of these bearings is on an eccentric. And getting that rod perfectly parallel was a little hairy, but came out well. The X-axis is a quadruple start, lead screw, direct drive to the stepper motor. That can go at about, right now it's set for 80 inches per minute. If you wanted to get more out of that, you'd have to gear it, which can easily be done. The Z is the third axis. Again, a stepper, direct drive to an Acme screw. The bearings are, we have a linear rail with two carriages. There's one on each side. And right now you can see we currently have the tool head set to just be a trim router with a clamp fit. And let's see. It's probably all the machine specifics. The laptop mount. Let's see if I can get far enough away here. Got the controller, laptop, joystick. Just runs off a standard parallel port. And it's a Xylex board. Let's see if I can get in here nicely. Think of two axes on a Xylex, and there's one more axis. I forget what the name of that other board is. The Xylex was a free axis, but one of them blew out. And on the back over there, that is the spindle control. Turns the motor on and off through your computer. So I'm going to run a simple program. It's a private doc sign. And we already have the beginning of it in the MDF. I I lined it up by eye, so hopefully everything's going to line back up. For the control software, we're using Mach-free. Yes, it's Mach-free, Archsoft Mach-free. I will load my G-code file, which is there. All right, I've already set, you can see, has a graphic of what the toolpath is going to do. But all right, we are ready to run.
Take a look. The Z was set a little bit aggressive there. It was a little bit deeper than...
It probably should have been. But you can see it didn't have any problem hogging out that material. I did that, so it was a little bit better, because we had already cut through once, so... well, it's probably all the main points of what I wanted to cover with the machine. It's a standalone, the entry type. Y can go up to 500 inches a minute, but we don't need that. I have it set at 120 right now as max. X right now is maxed at about 80. Can't really go any faster than that, being direct drive, even with a quadruple start. And right now the Y is set at, I believe, 20 for the rapid, 20 inches a minute. And again, that's direct drive, single thread. Probably don't want to go any faster, because if you lose steps, the machine doesn't realize it with the stepper motors. There's no encoders, so you can't lose steps if you want accurate work. And that is about it. Not a bad machine for the price. It was about $2,000 and about 6 months of hobby time to put this all together. It's a lot of trial and error, but it's a good machine. Great for a home shop or for a small machine shop that doesn't want to invest. I mean, a plasma cam, it's about the same size. That's about $7,000 just to get one to your door. Actually, that's without shipping. But all right, so that's it. Thank you.